is for you, I don't know. Okay? So, not yesterday, but the last time we had class, remember the problem we finished with was the box problem, right? So we're going to do another one. We did number 1. I'm on in your notes section 1.7. We did number 1 already. So now we're going to do number 2, but it is exactly the same thing. So if you were confused last time, let's see if we can get you up to speed on this one. Same thing. We got a 21 by 16 piece of paper. We're cutting these corners out to fold up the flaps and make a box, just like you did that one day in class. Right? Now, first thing we need to do, this is a 3-part question. First thing we need to do is write an equation for the problem. We're going to be maximizing it on our calculators, but I need an equation. So what would the equation be for the volume of this box? Length times width times height. So think about it. What's it going to be for the volume of this box? What is the length going to be? 21 minus 2x. Because the paper is 21, but you're chopping an x off this end and an x off this end, so that's 21 minus 2x. What about the width of the box? 16 minus 2x. And what about the height of the box? Think about taking these flaps and folding them up. What do we have for a height? X. Now, if you have your notes, and if you took notes last time, look at the equation for problem 1. Isn't it exactly the same thing? It's just using the whatever the numbers were for that problem. Every time you do one of these, it's going to be that minus 2x, that minus 2x times x. Okay? So that's it. That's the volume equation. Now we need to talk about the domain. And the domain is simply what x values are allowed in this problem. Think about it. How big of pieces could you tear off? Well, x has to be somewhere between 0 and something, right? You can't rip off negative paper, so the bottom boundary is going to be 0. What is the upper one for this one? 8. And why is it 8, Annie? You're exactly right. Why? Exactly. If you only have 16 inches and you're going to cut a piece off both sides, isn't 8 the most you can take if you only have 16? Yes. So this will always be 0 because you're never going to take negative inches. This will always be half of whatever your smallest dimension is. Whatever the smallest side is, you can only take half of that. So that will always be the upper bound for your domain. Okay? Now, the question says, find the maximum volume. Well, we're simply going to type that into our calculator. This is x min, x max, right? And we're going to type that equation in. What are you putting in for y min? Y is the volume. What's the smallest volume you can have? 0. Yeah, y min is always going to be 0. And then y max is what you're looking for. So remember we said just take a guess? And what do we need to see? The top of the hill? So if you take a guess and you don't see the top of the hill, then just guess a little bigger till you can get the top of your hill. So let's see what we come up with here. I still don't have internet, poor Katie. because I can't even email him to tell him. Hopefully he knows.
I think it just came back on.
Did it?
It's showing up on my iPad.
I don't, oh wait. It's doing that little bar thing now. Thank you for paying attention to that. I'll see if I can get him back. Okay, have you got a maximum yet? Let me see. Okay, Caden, our internet is not good today, so why don't you quickly copy these problems down?
Alright.
Just a second. I gotta go back and find the quiz now. Okay, so quickly copy these down. So there's A and B and C. Okay, see the problems? Copy those down in case I lose it again, all right?
Gotcha.
All right, so have you guys found a maximum yet? What did you find? I'm almost there. Just hang on. Then I want to hear what you got. You should have gotten a point. Oh gosh. Did you get, did it come out to be about 450? Is that what you got? Anybody get that for your maximum point? Okay, so let's answer the questions. Which of those numbers is the maximum volume? The y. Remember, when you put in your equation, y was the volume. So your answer is 450, this was inches, cubic inches. That would be your maximum volume. Then the second question says, how big were the corners that you cut out? Wasn't that your x? Isn't that what your x is? So how big are the corners? They are 3 inches square, right? 3 by 3. All right, anybody have a question about that one? Okay, let's look at your book now. And there are some really good problems in here, and I think it would behoove us to look them over. So the first one, again, I'm in section 1.7, which is on page 160 of the regular book. And I'm looking at problem 15. The height of a right circular cylinder equals its diameter. The height of a right circular cylinder. Now, does anybody even know what a right circular cylinder even is? What that looks like?
No clue.
So when you're done, Caden, come back to class here, because we're moving on. Okay, so this is a right circular cylinder. All right, a cylinder. And the problem states that the height, and this would be its height, and this would be its diameter. It says the height equals the diameter. That is the given in the problem. So I have some kind of a cylinder that's basically as wide as it is tall. Now, write the volume of the cylinder as a function of the radius. Write the that's what the question says. Write the volume of the cylinder as a function of the radius. Now, what is the formula, just in general? What is the formula for the volume of a cylinder? Get back, Jacob. Pi r squared h. Yep, that's exactly right. That is the formula for the volume of a cylinder. Now, gang, that is an awesome formula. The problem is it has too many variables. This question specifically stated, write the volume as a function of the radius. So the only variable you can have over here is r. So that means we have to get rid of the h. Now look at the problem. They will always give you what you need. What do you know about h? It's equal to d. And what do we know about d? What's the diameter? The diameter is 2 times the radius. So isn't h 2 r's? So guess what I'm going to do with this h? I'm going to take it out and put in 2 r's. So my volume is pi r squared 2r. Because in this particular cylinder, the height is the same as twice the radius. So my formula, my volume, is 2 pi r cubed. Now that is not a general formula that you're going to memorize. No, no, no. That's the formula for this particular cylinder. Okay? I know it's hard for you to imagine this, but you're going to do that over and over again in your calculus class. This idea of having to rewrite a formula in terms of just one variable. All right, let's try another one. 16. One leg of a right triangle is twice as long as the other. So here's my right triangle. Remember, the legs are the two that make the right angle. It says one leg is twice as long as the other. So could I do x and 2x? Write the length of the hypotenuse as a function of the length of the shorter leg. Well, this is easy. What equation are you going to get from this? What formula are you going to use? What? Oh, that's an interesting thought. That problem with using SOHCAHTOA is you have to involve the angles, and then you're going to have yet another variable. So what big, important, famous theorem do we always have in our back pocket when we have a right triangle? Pythagorean. So x squared plus 2x squared equals h squared. Biggest mistake that's made is kids forget this right here. You gotta put that in parentheses because you are squaring the whole thing. That's just the Pythagorean theorem, right? Okay, so x squared plus 4x squared equals h squared. So h squared equals 5x squared. Is that okay with everybody? Now let's read the problem again. Write the length of the hypotenuse as a function of the length of the shorter leg. Now the shorter leg is x. We are all good. This is all x's. But we need h. So what am I going to do to get h? Square root. So h equals x root 5. When I take the square root, square root of 5 can't do anything with, but the square root of x squared is x. So I have written the length of the hypotenuse in terms of x. That wasn't too bad. Let's see what's next. The base of an isosceles triangle. So I have an isosceles triangle. What does isosceles mean? Two sides are the same. It says the base is half as long as the two equal sides. So I'm going to draw a picture that looks like that. The base is half as long as the two equal sides. Does that make sense to you? Write the area of the triangle as a function of the length of the base. So I just need to write the area of that triangle. Thoughts? Jacob?
Well, the area of the triangle is times base.
Okay, so my general formula is 1/2 base times height. Okay, perfect.
You put down the middle.
So I have a base, but I don't have a height. So you're saying let's draw it in there. Now, this triangle is isosceles, gang. So when I draw that base, or excuse me, that height down to the base, it actually cuts the base in half. So this is half x and this is half x. That is not true in every triangle, but it is true in isosceles triangles. Okay? All right, where do I go from here?
Use the Pythagorean Theorem.
So now I've got another right triangle. So 1/2 x squared plus h squared equals 2x squared. Pythagorean theorem right here in this triangle. A squared plus b squared equals c squared. Remember, the hypotenuse is always the one over here. All right, so this is going to be x squared over 4 plus h squared equals 4x squared. Now, if you don't like dealing with the fraction, what could you do? Multiply everything by 4. So if that makes it easier for you, it makes no difference, kids. You can multiply everything by 4. You don't have to do that. But sometimes when we mix fractions and variables, people get confused. So it looks like, what? 4h squared equals 15x squared. So h squared equals 15 x squared. And h equals the square root of 15 over 2x. If I take the square root. Now, did I do something there that was confusing to anybody? What did I do all that for?
We'll figure out.
Now I have my height. All that was just to figure out what the height is. And then I can actually figure out my area. So if I multiply all that together, what am I going to get? Right, which is going to be root 15 over 4 x squared. Because I'm multiplying 1 times root 15 and 2 times 2. Remember when we multiply fractions straight across? And then x squared. That's it. That is the area of the triangle in terms of x. question about that? All right, next, I'm just going down in order. A square is inscribed in a circle. All right, do you know what that means? A square is inscribed in a circle. Here's my circle, and I have a square tucked in it just like that. That is a square inscribed in a circle. Write the area of the square as a function of the radius of the circle. Well, first of all, how do you find the area of a circle, of a square? Area of a square. S squared, right? Length times width, S squared. So I'm going to call this S. That's a perfect formula. But the directions said we don't want it in terms of the side, we want it in terms of the radius. So now you got to do what we did over here. You have to come up with another equation that will allow you to substitute something in place of that S. This is one of those obscure things you learned in geometry, but this is actually a right angle. Do you remember that god-awful chapter about quadrilaterals? Remember trapezoids, rhombuses, all that, and you had to memorize diagonals congruent, diagonals perpendicular, all that stuff. Remember all that? Well, one of the things in all that is the diagonals of a rhombus are perpendicular, and the squares are rhombus. So those are perpendicular. Which means, can I do another Pythagorean theorem right here? So r squared plus r squared equals s squared. So 2r squareds equals s squared. Wait a minute. Can I just plug that in? Isn't the area just going to be 2r squared? Because 2r squared is the same as s squared, and the area was s squared, so it's just 2r squared. That worked out. Easy. I'm going down to 20, so another one. So now I have a sphere contained in a cube tangent to all 6 faces. All right, I do not stand a chance of drawing that, so I'm just going to look at it from the side. There's my sphere inside a cube. Okay, so think about having a box and you drop a ball in and it fits just perfectly, snug up against all the sides. That's what we've got. We are going to write the surface area of the cube as a function of the radius of the sphere. So let me try this again. Find the surface area of the cube. What does that mean, surface area of a cube? What's that talking about? Doesn't that mean the area of all the faces? So a cube, if I'm looking at it from the side here, wouldn't this just be s times s? Wouldn't that be the area of that face? How many faces does a cube have? I heard somebody say it. 6. So 6s squared is the surface area of a cube. But we want this not in terms of s, we want this in terms of r. Well, this is super simple. What's the relationship between s and r? Aren't 2 r's and s? So I'm just going to take that and plug it in here. And 24r squared is our area. 24r squared. All right, one more of those, and then we're going to do some other stuff. One more. Number 20. An isosceles triangle has its base along the x-axis. All right, so isosceles triangle has its base along the x-axis with one base vertex at the origin and its vertex in the first quadrant. All right, so here's my isosceles triangle. And it's on the graph of 6 minus x squared. Actually, let me draw that in first. So 6 minus x squared looks like this. Oh, how did I know 6 minus x squared looked like that? Can someone tell me? Yeah, I use the BFF, sure. What's x squared? Parabola. Negative is going to turn it upside down. Plus 6 is going to move it up. This is the 0.06 up here, right? So there's the parabola. Now, I have an isosceles triangle sitting on that x-axis, and it tells me that my vertex is on that parabola. It also tells me one base vertex is at the origin. Okay. What am I supposed to be finding? The area, which we know is 1/2 base times height. Who's got an idea? Anybody? Jacob? Well, certainly I need the height. So to find the area, I'm going to need the height. So yeah, I think that's a good idea. Draw that right in. There's your height, right? Now, let's talk about that for a second. What is that going to make my base? Well, I can call my base x, and then each piece would be 1/2 x, or I'm wondering if it would be easier to call each piece x, because then this point right here is the point x comma y. This vertex would be at over x up y, right, or up h. Now, keep in mind that y is 6 minus x squared. So the height of this triangle is 6 minus x squared. Because that point has an x coordinate of x and a y coordinate of 6 minus x squared, because it's on that parabola. So now I'm done. I'm finished. My base is 2x, and my height is 6 minus x squared. So those are going to cancel, and I'm going to have 6x minus x cubed as the area of that triangle. Jacob?
I guess I'm so confused how we were able to split it into two x's, not just one half x.
Split it what?
How you were able to split the base into two x's and you didn't have to use the half.
Okay, I can, here's what I can do. I can call the whole thing x, but then this point up here is going to be 1/2 x. The x coordinate's going to be 1/2 x. And then I have to get my y, I gotta plug in 1/2 x. So that's gonna be 6 minus 1/4 x squared, which is fine, but then I just have fractions that I didn't have when I did it this way.
Okay.
Now, what I have to remember though is, Jacob, in my formula, go back to the original, what I had originally, my x stands for half the base, or the x coordinate of the vertex. That's what my x stands for. In your problem, your x stands for the whole base, okay? Which is fine. We just define our variables a little bit differently. Okay? All right, well that's great. Sorry we didn't get to a little bit more than that today, but that's all right. Sorry. All right, Caden, thank you. Did you send me the quiz?
Yeah, I did.
All right, thanks. All right.